Morning children, Sairam. Children, in the previous presentation we have discussed about the preparation of alcohols. So today I am starting with the preparation of phenol. Children, there are 4 methods by which phenols can be prepared. The first method is by use of haloarenes. You all know that haloarenes, they undergo nucleophilic substitution reaction at elevated temperature. Similarly, we'll use the same reaction here in which haloarene react with sodium hydroxide at a temperature of 623 Kelvin and 300 atm pressure and will result in the formation of sodium phenoxide, which on treating with HCl will result in the formation of phenol. This is the first method used for the preparation of phenol. The second one is the reaction with benzene sulfonic acid. Benzene, when reacts with oleum is H2S2O7, the purest form of sulfuric acid, which is then diluted to get the sulfuric acid. When benzene is treated with oleum, it results in the formation of benzene sulfonic acid, which on treatment with sodium hydroxide in acidic medium will result in the formation of phenol. So this is the second method. The third one is by using the benzene diazonium salt. Now first of all, we'll prepare benzene diazonium salt. You all know the diazotization reaction in which aniline react with NaNO2 and HCl and result in the formation of benzene diazonium chloride or whatever the halogen we take, benzene diazonium halide. Benzene diazonium halide has a very good property that whenever it reacts with water, it results in the formation of alcohol. So here it will be phenol. The last method that is used for the preparation of phenols is by use of cumin. Now, cumin is a hydrocarbon isopropyl hydrocarbon attached to the benzene ring, which in presence of oxygen will give cumin hydroperoxide. Children, you have to remember, this is not carboxylic acid group. It's not carboxylic acid. It is cumin hydroperoxide, which on treating with water in acidic medium will give you phenol. And the byproduct formed will be an ketone, that is CH3COCH3. So these were the 4 methods that are used for the preparation of phenols. Now some questions are there. Show how the following alcohols prepared by the reaction of suitable Grignard reagent on methanol. Now if we are taking methanol, the Grignard reagent that we are taking to form the alcohol should contain the alkyl group this attached to MgBr when react with methanol will result in the formation of this alcohol. Similarly, when the Grignard reagent is reacting with methanol, it should have this part. It should be cyclohexane MgBr and will result in the formation of this alcohol. Now see the next question. Write the structure of the product formed in the following reaction. Now see, it is prop 1-ene. Now it is reacting with water in acidic medium. The reaction will take place according to the Markovnikov rule, and the double bond will break and OH will attach on the second carbon and will result in the formation of propane 2-ol. Similarly, NaBH4 will reduce this compound and will result in the formation of alcohol. Here also aldehyde is there, NaBH4 is there, it will reduce the compound. Now next I am starting with the physical properties. Now you all know that in physical properties, 2 main things we have to study. The first one is boiling point and the second one is solubility. Boiling point is very much important. Now, if suppose we are talking about methanol and ethanol, then out of the two, methanol will have lower boiling point and this ethanol will have higher boiling point. It is because the molecular mass is more. So, if we have two alcohols, then the one which is having higher molecular mass will have higher boiling point. If suppose we are having two isomeric alcohols like propane 1-ol and propane 2-ol, in such cases the straight carbon chain will have higher boiling point because of more van der Waals forces. If it is a straight chain compound like 1, 2, 3 and OH, complete the valency yourself. Similarly 1, 2, 3 and OH, then out of these two, this compound will have higher boiling point because it has more surface area, so van der Waals forces between the two molecules will be more. Now next is like your phenols are there. Phenols also, if see children, the reason behind the higher boiling point of alcohols and phenols is the hydrogen bonding. What their boiling point should come according to the molecular mass, it is higher than that because of the hydrogen intermolecular hydrogen bonding. That means two molecules are joined together by hydrogen bond, so we have to supply more energy in order to break that hydrogen bond. Now if suppose we compare alcohols with other classes of compounds like hydrocarbons, ether, haloalkanes and haloarenes of around similar molecular masses, then alcohols will have highest boiling point because of hydrogen bonding. The least boiling point is of hydrocarbons, then is of ethers, and then is aldehydes, you can say. Now for example, one example is given here. You all can see we have ethanol, methoxymethane and propane. Now these all are having almost similar molecular masses. Ethanol is 46 and methoxymethane is also 46. Propane is around 44. You can say it is of comparable molecular mass. Now if we see to the boiling point, the highest boiling point is of alcohol because of hydrogen bonding. On the second place comes the ether, methoxymethane, which is having slightly less than you can say not exactly, slightly, very less than compared to alcohols. And the least boiling point is of propane because very less intermolecular forces of attraction are there. Now coming to the next important thing, that is solubility, another physical property. Solubility, you can say the alcohols and phenols, they easily dissolve in water because they are forming the hydrogen bond with water. Now hydrogen bond is possible due to the presence of the OH group. So because of the presence of OH group, hydrogen bond is formed, so they dissolve in water. But when the length of the carbon chain is increasing, you can say the hydrophobic part is increasing, then the solubility decreases. Now next is the chemical properties of alcohols and phenols. See children, you have to remember these alcohols and phenols, they are versatile compound. The meaning of the word versatile is that they can behave as an acid as well as a base. Now you all know there is a bond ROH. Now if suppose this bond will break, then it will give H positive and behave as a acid. If suppose this bond is breaking, then alcohol will give OH negative and will behave as a base. Now we have to see when does it behave as an acid or when does it behave as a base. Now children, on the basis of giving H positive, giving OH negative, you can say the alcohols are Bronston acid. You cannot say that they are Lewis acids because Lewis acids are those which can accept a lone pair of electrons, but actually they are giving H positive ions, so they are Bronston acids. Sometimes they are behaving as Bronsted bases also. Now in what cases they are behaving as Bronsted acid? That means in what cases the bond between carbon and hydrogen will break. See, the first is when they react with any metal. Whenever they react with any active metal like sodium, potassium or aluminium. Like here it is reacting with sodium, aluminium, sodium hydroxide. In all the four cases, the bond between the oxygen and hydrogen is breaking and is resulting in the formation of sodium alkoxide, aluminium butoxide, sodium phenoxide, sodium phenoxide. So whenever they are reacting with active metals, they are behaving as a acid. Now see the order of acidity. If we see primary, secondary and tertiary alcohols. See children, in case of tertiary alcohol, there are three alkyl groups attached on the sides of the carbon containing OH, which are increasing the electron density over this carbon. Now carbon is electron rich, it will supply electrons to oxygen. Oxygen will become electron rich, so it does not need to take electron from the bond between oxygen and hydrogen, so the bond will not break easily. Whereas if we compare with this primary alcohol, then in case of primary alcohol only one carbon atom is there, one alkyl group is there, which is giving its electron towards the carbon containing OH. So electron density will not increase much, so it will take the electron from the bond between oxygen and hydrogen, so the bond will break and H positive can easily go out. So if we compare the order of acidity, then primary alcohols are primary alcohols are more acidic compared to secondary, which in turn are more acidic compared to tertiary. Now coming to the phenols, the acidity of see children, phenols, they also have got acidic nature. It is because you all know benzene ring, it is electron rich. The electron will rotate inside the benzene ring. The electron will come from the oxygen atom, which is directly linked with the benzene ring. Now the reaction of phenols with metals like sodium, aluminium or sodium hydroxide, they again indicate the acidic nature of phenols. The hydroxyl group in phenols is directly attached to the sp2 hybridized carbon atom of the benzene ring, which act as electron withdrawing group. This benzene ring is electron withdrawing group. Now it is taking the electron pair present on oxygen atom. Oxygen is becoming electron deficient. Now oxygen is becoming electron deficient. The charge is distributed on the phenol because of the resonance. So there is a positive charge on oxygen atom. So it will take the electron pair shared between oxygen and hydrogen. The bond will break. This bond will break and will result in the formation of a sodium formation of a phenoxide ion and will behave as an acid. Now, due to the higher electronegativity of the sp2 hybridized carbon atom on the phenol, the OH group attached, the electron density decreases on oxygen. So, the polarity of the OH bond will increase and will result in the increase of ionization of phenol compared to that of alcohols. So, we all can say that phenols are more acidic than alcohols. This statement you have to remember. Due to the effective delocalization of negative charge on the phenoxide ion, it is more stable. So, phenols are more acidic than alcohols. Now another case when again phenols and alcohols behave as an acid, when the bond between the oxygen and hydrogen will break, is the esterification reaction. That means whenever an alcohol or a phenol react with carboxylic acid, acidic anhydride, or alkyl chloride, then again the bond between oxygen and hydrogen will break and they will behave as an acid. Now next is the behavior of alcohols and phenols as bases. When do alcohols and phenols behave as bases? Now you all know that alcohols or phenols have ROH bond. Now whenever this bond will break, they will give OH negative ion. That means they are behaving as bases. Now in what cases this bond will break? See, we have the first, that is whenever alcohols or phenols react with halogen acid, the bond between the carbon and oxygen break, they give out OH and the halogen is attached to that. This is the first case. Second is again the reaction with phosphorus trihalide. In that case also the bond between the carbon and oxygen will break, they will give OH. Third is the dehydration reaction. Dehydration reaction is alcohols when heated in presence of an acid, they result in the formation of an alkene. The bond between carbon and oxygen will break. Along with that, the hydrogen present on the adjacent carbon, the beta carbon, will also go out. This is just the opposite of the reaction that we have done earlier, that is acid catalyzed hydration of alkene to form alcohol. This is acid catalyzed dehydration of alkene to form dehydration of alcohol to form an alkene. The mechanism is also similar. In the first step, the alcohol react with H positive ion and form the protonated alcohol. In the second step, the formation of carbocation takes place, and in the third step, the deprotonation takes place and an alkene is formed. Next is the oxidation reaction. Now you have to remember, oxidation means either the addition of oxygen or removal of hydrogen. Here in case of oxidation, the removal of hydrogen takes place. The H2 goes out. One hydrogen goes from oxygen and the other hydrogen goes from the carbon which is attached to the oxygen atom, and H2 are given out and a carbonyl compound is formed. Carbonyl means CO type compound is formed, that can be an aldehyde or it can be a ketone also. Now as we have done the reduction of aldehydes and ketones, when aldehydes are reduced, they give primary alcohol. Similarly, when ketones are reduced, they give secondary alcohol. The similar are the reaction. These reactions, they're just the opposite of it. Whenever a primary alcohol undergoes oxidation, it gives an aldehyde. If we use a strong oxidizing agent, it can give a carboxylic acid also. Now, the oxidizing agent that we can use in case of alcohols is CrO3. We can use PCC also, and it does not affect the double bond also. Now when we are using alcohol containing double bond, then we are using pyridinium chlorochromate for the oxidation and result in the formation of an aldehyde. When a ketone is there, again we can use CrO3. But for the preparation of carboxylic acid, we need to use the strong oxidizing agents such as acidified potassium permanganate. Now tertiary alcohols, they can also be prepared by using the primary alcohol, by passing the vapors of primary alcohol through a carbon rod which is heated at a very high temperature of 573 Kelvin. It will result in the formation of aldehyde. Now ketone will result in the formation of secondary alcohol will result in the formation of a ketone, and tertiary alcohol will result in the formation of an alkene. That is the you can say the tertiary alcohol will give a alkene. Now children, I'll wind up for this for today with this much. Next we'll start with the reactions of phenols in the next presentation. Thank you. Sai Ram.